Hello class, welcome to this lesson on 7.6. So we're going to talk about translating trig functions. So basically this is a continuation of 7.4 where we are graphing sine and cosine functions. 7.5 we're skipping that because we're not focusing on graphing tangent at this time. So we're skipping from 7.4 to 7.6 for this. Think of this as a part 2 to 7.4. So we're going to continue graphing sine and cosine more specifically rather than just using technology. But we're also going to introduce another transformation, a translation of sorts. So the review vocab, or the actual new vocab term is the phase shift. So the essential question is, how can we find and use translations of graphs of trig functions like sine and cosine? So we're going to quickly review the graph of the sine and cosine, which was 7.4. We're going to review that real quick. Remember that the general form of sine or cosine, remember just replace sine with cos in this formula, is you have an a term, then you have a b on the inside, x minus c, and then plus d. Now we haven't talked about what the c term stood for yet. We're going to actually talk about that today. But we did talk about the rest of the terms. The a term, remember, was the amplitude. Now, I didn't mention this in the previous lesson, but a could be negative. It's possible for it to be negative, and if that's the case, make sure that the amplitude is positive. So the amplitude can never be negative. So just take the absolute value of a. Similarly for b could be negative, but when you calculate the period, which is 2 pi divided by b, make sure that that b is positive. Take the absolute value of it, because a period cannot be negative. Remember that the periods essentially was the distance or time. You can think of it as the time, but basically it's the distance from one wave to another when it starts to before it starts repeating. Okay, so the initial and the ending point of a full cycle of the wave. So basically a distance from peak to peak or trough to trough, if you think about it like that way. And then the b term also helped you find what we call the wave number, or the number of cycles from 0 to 2 pi. So if the b number were 2, that means you'll see two full waves from 0 to 2 pi. And the d term was the midline, and this could be negative. So if the d were positive, it would be shifted up, and if the d were negative, the graph would be shifted down. Okay, so the a could be negative, but remember, if the a is negative, that means it's a reflection about the x-axis. And like I said earlier, the b could also be negative. If that were the case, it would reflect about the y-axis. Okay, so what we're going to do is we're going to quickly graph the sine and cosine just to kind of review. So remember that the sine had the snake-like shape starting at the origin and peaking at pi over 2 at a value of 1, dipping down to 0 at pi, and then going further down, negative 1 at 3 pi over 2, and then going back to the 0 mark at 2 pi. And that was the snake-like shape that I mentioned. And then it continues, this is one period of the graph. If you were to extend it on the other side for another period, then it would look something like that. All right, so that's the sine function. Now the cosine function actually starts at the top, starts at the 1 rather than at the origin. So we're going to draw that one real quick. So for the cosine, starts up at 1, then it goes to 0, then pi, and negative 1 at pi, back to 0, and then back up to 1. So we have a graph that looks like this. And this has that characteristic U shape, right? That's what I call it. And then of course you can extend it and get another period of that graph. Now also notice, we're gonna emphasize this. The sine and the cosine look remarkably similar, if you notice. They have that we call that the sinusoidal shape, right? Where it goes up and down. The typical wave-like fashion when you think of a wave, right? Now they're actually the same graph, but they're actually shifted in different directions. So I'll show you that real quick. So if I were to graph the sine, remember that the sine, if I were to superimpose it on this, this is how the sine looks like. They're the same shape, but they're translated horizontally different, right? So if I were to take this point right here and move it, well, then I'm going to get the same exact graph. I'm going to get this part of the graph, right? And then that will, in that case, be the same exact graph if I were to move it over to the left by pi over 2. Similarly, if I were to take the cosine and move it to the right pi over 2, I will arrive at the sine graph. So we're going to actually show you this using technology here. We're going to show you this on Desmos to kind of illustrate this idea that the sine and the cosine are really the same graph. All right, so this red right here is the sine graph. So we're going to do, I'm going to try to move this back. Okay, so this is the sine graph, right? Notice it has that snake-like, starts at the origin, has that snake-like. Now, if I take that graph and I shift it to the left by pi over 2, we're going to do that now, then we arrive at the graph of the cosine. So that way you can kind of picture that. And there's the graph of the cosine. So again, I'm going to move it back to where it was at the 0 mark. And that will be my sine graph. Then I'm going to draw the cosine. I'm going to go ahead and type in cosine. Okay, and that's my cosine graph, the dark red. So now if I take the light red and I move it over, then you can see that they overlap. So they're really the same graph. Okay, so the C was the, so what is that C term? Notice that I adjusted that C term, and that C term actually shifted it left and right. The D term, if I were to shift it, if I were to move this D bar right here, it actually shifts the midline, shifts it up, down, right? That's what we call the midline. And then if I were to adjust the B, well, if I adjust the B, if I increase the B, then that means I decrease the period, or you can think of it as increasing the amount of waves. So let me increase the B, and then you see, look at how many waves that is. So let me get rid of the cosine graph here. So if I increase the B, then what happens is my frequency increases. You can visually see that when the frequency increases, I get a lot of waves, right? The wave number increases. So that's what happens when my B increases, is that frequency starts to increase. The waves become more frequent, which is why we call it frequency. And then as I decrease it, then the wave extends, okay? This is very applicable. When you're talking about physics and you're talking about light waves, the colors that you see in the light spectrum depend on the frequency of the light. So higher frequency light, such as the blue and so on, and the purples, as opposed to the low frequency wavelengths, such as the the reds and so on. But this gives you an idea, of where it's applicable. All right, so that is the sine and the cosine. So let's go ahead and discuss the phase shift. So that's what the C term does. The C term is called a phase shift. It helps you with the phase shift. So it's a horizontal translation of a periodic function indicated by the C term. So now we know what the C term does. So the phase shift is actually going to be the C value. So let me go ahead and adjust this. It should be the C value, not the negative C value. Okay, so the phase shift is given by the C term. So then what happens is that if the C is positive, so if the C term is positive, then that means that the phase shift is going to be positive, which means it's going to be shifted to the right. A positive phase shift means a shift to the right. A negative phase shift indicates a shift to the left. So if the C were negative, the phase shift would be negative. All right, so note that since the phase shift takes care of the horizontal translation, the vertical translation is already taken care of by the D term. Remember the midline. We showed you this graphically, but when the D was positive, it shifted the graph up. When the D was negative, it shifted the graph down. So we mentioned that the graph of sine and cosine are simply the same graph offset by a phase shift of pi over 2. And if you recall, the phase shift of the pi over 2, it's the same thing as 90 degrees. So it's the same thing as a 90-degree angle. All right, so basically, if we started out with the sine graph, we mentioned that in order to get the cosine, the U-shaped graph, we have to take the cosine graph and shift it to the right by pi over 2. So this to the right means it's going to be a positive c term, right? So in that case, the c is going to be positive pi over 2. So pi over 2 to the right, and to the right means that the c is going to be positive pi over 2, not negative pi over 2. But when we plug it in, remember that the form of the cosine or sine is cosine bx minus c, right? So if I could plug in a positive pi over 2, well, that's just going to make it x minus pi over 2, which is what I have here. Okay, which means that it's a shift to the right because the c is positive, right? Even though you see a minus there, that minus is from the formula, not from the c. Now, if I were to take, similarly, if I were to take the sine graph, so this time I'm going to take the sine graph, and I'm going to, let me draw the cosine graph again here. If I were to take the sine graph, then I would have to take the sine graph and shift it to the left in order to get the cosine graph, right? So in that case, this is going to be a shift to the left by pi over 2. And shift left means that c has to be negative, right? So that means that c is negative pi over 2. And c is negative, well, then we get a double negative situation going on here, right? Which makes this into a positive. So which means that we're looking at the right scenario right here. So that's a shift left by pi over 2. Remember that when we write this out, it's really a double negative because the formula itself has a negative, but the c itself is positive, and a double negative makes it into a positive, okay? So that's a little trick with these signs, but just remember, if you see a plus in the function that in the inside, that means it's a double negative, which means that the c is actually negative, which means it's a shift left. If you see a negative, that means the c is really positive, so it's a shift to the right, okay? And and the reason why it's done this way is to obey the typical transformation laws, with a minus on the inside being right, a positive on the inside being left. All right, so in any case, this is what it means to shift horizontally. So how do we identify phase shifts? Well, we kind of looked at one example, but let's look at some others. So let's say we have something like, if we have something complicated on the inside, a b term on the inside, how do we go ahead and do that, identify the phase shift? Well, for functions that have a b term and a sum, you need to factor the b term to identify the phase shift. So notice in the formula for cosine and sine that, you know, when you're looking at this complicated inside right here, this complicated inside, that b term is usually factored out of the expression. And that's important. That b has to be factored out before you can identify the c, okay? So, for example, let's say we have the function 2 cosine of 3x minus 12. Well, in this case, this is the b term right here. You got to pull that out. So we're going to pull the 3 out. So if we pull the 3 out, then, you know, now this 3 is pulled out, right? So then we know that 3 times 4 is 12. So if I pull out a 3 from 12, well, that turns it into a 4, right? So that's how we get b times, so this is my b x minus c term now. Now you can clearly identify the c. The c is clearly positive 4. And if the c is 4, that means it's a shift to the right of 4. So now in this case, c is 4, so phase shift is 4 units to the right. Let's look at another one. So let's say we had negative 2x minus 5. So this time we had to pull out the negative 2. So we're going to pull out the negative 2. In that case, how do we pull out a negative 2 from like 5? Well, all you got to do is take 5 divided by 2. Just like when we pull out a 3 from 12, we really did 12 divided by 3, and that's how we got 4. Same thing here. In order to pull a 2 from a 5, well, we just got to do 5 divided by 2. All right. So now notice that since you're pulling out a negative from a negative, that makes it into a positive. And that's why we got a positive right here. Okay. So it's just 5 over 2. Just convert it to a fraction, and that's your phase shift, right, when you pull out. All right, so then we have the negative 2 out, and now this positive indicates that we have a double negative situation going on, right? So that the C term, the actual C term, is this part right here. So that's my C, which is also coincidentally my phase shift, okay? So that's my phase shift term, which means I know it's shifted to the left by 5 over 2, all right? Okay, so let's look at some examples of graphing and identifying the key features. All right, so let's look at the function 3 cosine of 2x plus pi over 4. So first off, let's identify the transformations. Remember that this is of the form a cosine, or we want to make it of the form plus d. Right now, we need to factor out that 2, right? Because it's not in the b times x minus c form. So that's the first thing that we want to do is pull out that 2. So we have, so let's go ahead and do that right here. So we have 3 cosine. Now I'm going to pull out that 2, so that means I have 2 outside. And then I don't really have a d term here, right? The d term is actually 0. So my d term is actually 0 here because it's non-existent. All right, so now if we pull out a 2 from 2x, that's just going to be x, because 2 times x is 2x. If I'll pull a 2 from pi over 4, how do I do that? Well, like we said earlier, you just take the number and then divide it by whatever you want to pull out. So really, it's pi over 4 divided by 2. So let me go ahead and do that. So it's pi over 4 divided by whatever I want to pull out in that case. So pi over 4 divided by 2 is going to be pi over 8. Okay, so again, if you use the KCF in order to do that, pi divided by 4 divided by 2 over 1, keep, flip, and change. You flip the 1 over 2, the 2 over 1 to 1 over 2, and then that multiplies straight across, and that'll give you pi over 8. So I'm going to change this, go ahead and change this to a pi over 8. All right, and now since we got a double negative situation going on here, this is really the same thing as minus negative pi over 8. So now I know that my C term is negative pi over 8. So we have C, which is my phase shift, is negative pi over 8, which means to the left. So pi over 8 to the left. And my amplitude is, I'm just going to write AMPL, is my A term, right? My absolute value of A. So it's just going to be 3 in this case. My midline is at y equals 0. That's my D term is 0. And then that's really, I think that, oh, and then the period, we have to do the period. So the period is given by the T, and it's 2 pi divided by absolute value of B, right? And the B term in this case is what we pulled out. That was the 2. We pulled out the 2. So we got 2 pi over, right here, that's my B term, I'll circle it right there, over 2, which is going to be pi. So my period is pi, and then we'll do our frequency, just in case they ask for that. Our frequency is 1 over our period, which is 1 over pi. And then lastly, we'll do the wave number, the number of cycles from 0 to 2 pi is simply the B term, the absolute value of B, which in this case the B is 2. So we should see 2 waves from 0 to 2 pi within that 0 to 2 pi range. All right, so now that we got all this information, let's go ahead and do the graph. So now we know that the midline is at 0, so I'm going to go ahead and the midline is basically the x-axis. All right, and then my amplitude is 3, so I know the distance from here to the peak is going to be 3. So basically, and we're at the negative 3. So 3 up, 3 down from the midline. And it's a cosine graph, so that means that it does the U shape, right? So I'm going to go ahead and do the U shape, like here, here at pi over 2, here at pi, here at 3 pi over 2, and then here at 2 pi. So it has that shape. I'm not going to draw the shape yet because I'm going to transform it to get the new graph, but it has the U shape. So now the period is actually pi, which means that I need to take my original period, I need to take my original 2 pi here, and I need to divide it by 2, right? Because I want that to be pi. So in order for that to be pi, I need to divide it by 2 in order to make it into pi. So I'm going to divide everything by 2 here. So in that case, this is no longer going to be pi over 2, right? It's going to be pi over 4. So I'm going to take that divided by 2, and now it's going to be pi over 4. So I'm going to change that to a 4. This is going to be pi over 2. This is not going to be 3 pi over 2 anymore. It's going to be 3 pi over 4 because we're making it half as small. And then this is now going to be just pi, right? If that cancels out. So now we just got pi, not 2 pi. And that's a quick little trick so that you don't have to like make the graph smaller. You technically made the graph smaller by changing the axis, right? So now we have a period of pi. We have it from 0 to pi, which is a period of pi because it ends here at pi. Now that we've got a period of pi, what we're going to do is we're going to translate this. So we're going to move it over to the left by pi over, according to the graph, pi over 8, right? The phase shift was pi over 8. So we're going to shift it to the left by pi over 8. So every single point that you see here is going to be shifted to the left. Now pi over 8, remember this is pi over 4, so pi over 8 is like halfway, right? This halfway mark. This is pi over 8. So these little marks, I'm going to go ahead and mark them, are pi over 8s. Okay, and you could be approximate with it if it's tough to identify, but as long as you get a good rough sketch, that's fine. So pi over 8 is going to be shifted just a little bit. So we're going to take this point, shift it there, take that point, shift it there, this point, shift it there. You can imagine we're shifting all of the points. Okay, so I'm going to do it with the red. So we have a new point there. New point here, new point here, everything shifted to the left by the phase shift, and a new point there. And now it's shifted to the left the way we want it. And there's our graph. It would have been in the block, but then it shifted to the red. So that's my graph of my cosine. Now, if I want to do another period, I would just extend it and just do another period of it. Okay. All right. So that's example 1. So let's look at another example. We got 3 sine of pi x minus pi over 4. So again, let's go ahead and pull out the b term. Remember, that's my b term right there. So I want to pull that out. So 3 sine. So if I pull that out, I get pi. If I factor it out, we got a plus 1. That's my d term, by the way, and the plus 1. So if I pull out a pi from pi x, that's just going to be x. If I pull a pi from pi over 4, well, then that means the pi cancels, and that leaves me with 1 over 4. Okay? Again, if that's confusing, just do whatever you start out with, divided by whatever you're pulling out. If you divide that by whatever you're pulling out and then use a KCF, take that and then you flip the 1 over pi, and then the pi is canceled, and you can kind of see it's 1 over 4. So that's just a quick way of doing that. All right, so now we know that our phase shift, which is C, which is our phase shift, is actually going to be positive 1 over 4 because there's already a negative in the formula right there. So it's going to be pi, or not pi over 4. It's going to be 1 over 4, which means to the right. All right, so that's my phase shift. My amplitude is 3, which is my A term. And then my period is T equals 2 pi divided by B, and B is pi. So then notice that the pi's cancel, leaving me with a period of 2. And then our frequency is 1 over the period, so it's 1 over 2. So that frequency just tells us, it's just telling us the reciprocal. It's saying, it's, you know, as the period gets bigger, the frequency gets smaller. That's basically what it's showing, that relationship. All right, and then the number of cycles, or the wave number of cycles from 0 to 2 pi is equal to the b term, which is, the b term is pi. So that means that we get 3.1415 ... waves per cycle 0 to 2 pi, which is kind of weird to think about, but that is according to what we're looking at here. All right, and then we have our midline at y equals d, and the d we said was 1. Okay, so let's go ahead and graph this real quick. The midline I'll do in purple. So we have a midline at the 1. So I'm going to draw that first off, like that. All right, now we said that the amplitude is 3, which means we're going to go 1, 2, 3, 3 units up and then 3 units down, right? So that's what I'm going to be looking at. So that means I'm going to go up to the 4 up here, because 1 plus 3 is 4. And then if I subtract here, I'm going to go down to the -2. Those are the ones that I'm interested in. All right, so now we know that it's a sine graph, and a sine normally starts at the origin, right? But then since it's shifted up, it actually starts here. So we know that the sine starts, you know, in the middle of that midline, right? That middle central point. And then it goes up, right? It goes up to the amplitude, then down to the 0, our baseline basically, and then down here, and then up here back to the baseline. So those are my points. And then I'm going to adjust the pi's here. So we know that our period is 2, which means that we have to take the 2 pi that we normally have and divide it by pi, right? So we're going to divide all of these by pi. So basically they just cancel out. If you think about it, the pi's just cancel out. So I'm going to go ahead and cancel out the pi's here. And I'm going to do this in red. So this will go away. This will go away. This will go away and become 1, right? It doesn't just become nothing. It becomes 1. Pi divided by pi is 1. And then if I take out the pi here, then that would be a 1 over 2. Okay, so I'm going to go ahead and zoom in on that so you can kind of see. So basically we have 1/2, 1, 3 over 2, and then 2. So that's where our new x-axis. Okay, so that's dealt with. Now we know that the period here is 2. It's going from 0 to 2. And now we got to do the shift. So it's a horizontal shift by 1/4. So we're going to shift everything to the right by 1/4. So keep in mind, each of these is 1/4. Each of these units is 1/4. So that's 1/2, 1/4, 1, 2, 1/2, 3/4, and so on. So each of those little ones is 1/4. And we're going to shift it to the right. So this is going to go to the right. This is going to go to the right. This is going to go to the right, and so on. So our new points are going to be over here, over here, over here, and over here. So then we're going to draw our graph of our new sine. Oh, this is going to be moved too. So this is like over here. All right, and there's my sine graph. Notice that it is shifted, right? And shifted up as well. All right, so now what we're going to do, the last thing we're going to do is we're going to write an equation involving sine and cosine that models the function represented by the graph. So I'm going to show you how to actually identify the equation from the graph. So this time we have a graph here instead. How do we identify the sine and cosine equivalent of this guy? Well, let's go ahead and find the midline. Remember that to find the midline, you figure out what the maximum and minimum points are. So if you look at this, the maximum is 3, and the minimum is -1. It's kind of hard to see, but that's the minimum. So that means my amplitude has to be halfway between those two, right? My midline. So that means my midline has to be halfway. So that means it's going to be halfway between 3 and -1. So you average, take them and divide by 2. And that's how you figure out the halfway point. Just average them. 3 plus -1 is 2. 2 divided by 2 is 1. So my midline is y equals 1. Okay? So that means that this right here is my midline. All right, so we know our midline, which means that we know our amplitude now. The amplitude is the distance from here to here. So what is that distance? Well, that distance is 3 minus 1, that's a distance of 2. So we know that our amplitude is 2, which means our A is 2, right? We know our A now. Okay, so we know our amplitude, we know our midline. How do we figure out our period and stuff like that, and our B term? Well, to figure out the B term, you need to figure out, well, let's figure out the period of the function. So let's do that in red. Okay, so the period is, you want to see where it starts repeating, right? Where it stops repeating. So if we were to, you can start anywhere on the graph, by the way, as long as you trace it to where it repeats. So if I start here, right? Then we know that we'll keep going, we keep going. And then this part is where we're going to stop. That's where it stops repeating, right? After that point, it's going to start repeating after that point. So that's one period, one cycle, okay, from there to there. So then what is that distance from there to there? Well, that distance is given by this and given by this. So basically, we got to subtract those two. So we got to subtract those two numbers, right? So we got to subtract pi over 2 and 3 pi over 2. So 3 pi over 2 minus pi over 2 is 2 pi over 2, which is pi. And that's my period, guys. So my period is pi. Okay, so if my period is pi, then I could find the B term. Let's do that off to the side over here, just because we need room. Okay, so if I know that my period is pi, well, so this is pi, but the formula for the period is 2 pi over b, right? That's the formula. So let's go ahead and solve this. Let's put pi over 1, and then we'll cross multiply. So 2 pi times 1 is 2 pi. Pi times b is pi times b. And there's my equation. So notice that the pi's cancel, leaving me with b equals 2. So the b has to be 2. So there's my b. So now we know A, we know B, we know the period, we know the midline, so we know D, right? We know D. D has to be 1 because that was my midline. And we need to find C next. So how do we find C? Okay, well, to find C, let's go ahead and that depends on if we're talking about sine or cosine. So if we wanted to talk about sine, well, the only way that this will look like a sine is if you take this point right here and you move it over this way. You got to move it to the origin, which is like the baseline, which the midline here. If you take that, you move it there, well, then all of a sudden you get something that looks like a sine, right? Like that. So that means that we got to take that point and move it over. How much do we move it over? Well, we move it over by, well, this is right here. This right here is pi over 4. So that means you got to move it over by pi over 4. So we got to take it, shift it left by pi over 4. And shifting left by pi over 4 means it's going to be a positive. Shifting left means it's going to be negative, right? A negative phase shift. However, keep in mind that since we're shifting it left, we got to shift it back to the right, because remember, we want the original graph. So that means we're really going from the green to the red. So if we want to go from the green to the red, which is my actual graph, by the way, we want the actual graph, right? We don't want the green graph, we want the red graph. But to go from the green to the red, I got to shift it to the right, do the opposite, pi over 4. So that means it's really a phase shift that is positive. So my C is pi over 4. So my C is pi over 4. for sine. Okay, so then my equation for sine is y equals a, which is 2, sine b, which we said b was 2, x minus c, and c we said was positive pi over 4. And then d we said was positive 1. And there's my equation for sine. Now let's do cosine. Cosine is going to be the same, but the phase shift is going to be different. So we got to figure out the phase shift. So again, I'm going to use green here because I want to show you how it looks like. Okay, so now what we want to do is we want to make this look like a cosine, right? So to make this look like a cosine, I need to take this red point right here, and I need to move it over here. Okay, if I move that over there, then I get a graph that looks like the cosine, right? Where it has that peak, and then it does the U-ish shape, right? So I need to take that and move it up to there. So that means I need to take the green and go from the green to the red. Going from the green to the red means that I'm shifting to the right by, in this case, what's that distance? Well, that distance is pi over 2, right? So I need to shift it to the right by pi over 2. Okay, so again, that means my c is actually pi over 2, so it's going to be minus pi over 2. The minus is not from the c, by the way. The minus is from the formula. So just so that won't confuse you, that minus is from the formula, but the c is pi over 2. All right, so that's my sine and cosine graph. That's my equation. So we're going to do one more of this to give you an idea. Okay, so again, the midline here is halfway between the 4, that's a 4, and a negative 2. So we're going to do it over here. 4 plus negative 2 divided by 2. 2 divided by 2 is 1. So my midline is 1, which is my D. All right, my amplitude, that distance right there, is actually going to be 3 units. Okay, so my amplitude is 3. So we know A is 3, we know D is 1. My period, so let's pick any 2 points on there. So let's do there and there. Actually, let's make it easy on ourselves and do here to here, right? So it starts from 0 here and it ends at the 2, right? So the distance from 2 to 0 is 2 minus 0, which is 2. That distance right there is 2 minus 0. So my period is actually going to be 2. So my period is 2, and the formula is 2 pi over b. All right, so that means 2 over 1, cross multiply. 2 times b equals 1 times 2 pi. So now go ahead and divide by 2 on both sides, and the b is equal to pi. So we know b is pi. All right, so b is pi, a is the amplitude, d is 1, amplitude is 3, and then we need to figure out our c, right? So what's the phase shift? So let me go ahead and write my sine equation first. So we have 3 sine b is pi. We need to figure out the c term, of course, and then plus 1. All right, so what's my c term? Well, you're going to take this graph. This needs to look like a sine. So that means, essentially what that means is that you got to take, and I'm going to do this in green to get rid of all, and I'm going to get rid of all this. So you got to take this part right here. Yeah. So we got to take this part over here. We got to take that and we got to move it over to there. If we take that and move it over there, then it'll look like that, right? If we take that and move it, and then we'll have the downward part, shifting as well, right? So we got to take it and move it over there, and that way we get the traditional snake-like shape, right? keep in mind that this is my new origin. My new origin is that middle point at the purple. Okay, so therefore I got to take it and I got to shift it over by 1. It's going from -1 to 0. So I got to take it and shift over 1, which means that if I want the red graph, I got to go from the green to the red. Means I got to shift it to the left by 1, which is a -1. So my C is actually -1 here. So my C is -1, which means that this turns into a positive. So it becomes pi x plus 1 plus 1. All right, so that's my sine. Now let's finish off with the cosine here. So we have 3 cosine. So now, if we, and let me do this in green, and erase all of this. All right, so now if we want it to look like the cosine, well, we got to take this part and we got to move it to the peak, right? We got to move that peak over there. So how much do we move it by? Well, this point is at the -½ mark. So we got to take that and move it over by 1/2. Okay, and that will give us our green graph. So then it will look like that, which is what we want. All right, so that means that we got to go from the green to the red. So instead of shifting it to the right, we're shifting from the green to the red. So it's left by 1/2. So we're shifting to the left by 1/2. So it's -1/2 or -0.5, same thing. So then we have x minus, and then we're shifting to the left by 1/2. And then our d was 1. All right, remember that this becomes a positive, so it becomes x plus 1/2 instead of minus negative. All right, guys, that was a lot for this video. I want to stop here, and I hope that you learned something from this video. There's a lot of things going on, and I will, of course, as usual, I'll see you in the next one.